Hello everybody. So let us discuss now the second case, that is refraction from denser to rarer medium. Again, here there are two cases. The first is when images formed is real. Okay, so this is how we place the convex refracting surface. Alright, so here again we have xpy to be the convex refracting surface. It is a denser medium having refractive index mu2. So it is placed in a rare medium where the refractive index is mu1. Always denser medium refractive index is mu2 and rarer medium refractive index is mu1. That you have to remember. Then the object is placed in the denser medium. Okay, why? Because light is now going from denser to rarer medium, and light always comes out from the object. So therefore the object is placed where? In the denser medium. So the ray of light, you can see here there are two rays of light. One ray of light will go directly along the principal axis. Another ray of light will go like this, and after refraction. Now what is happening here? Light is going from denser to rarer. So instead of going straight, again let me just show you that scale once again. So if you look here, instead this line here, instead of going straight like this, it bend away from the normal. Yes or no? Why away? Because it is traveling from denser to rarer medium. Got it? So it bends like this, and these two rays, they meet and they converge and they meet at this point where the image is formed. Okay, so I there is the real image. Understand? Okay, C here is the center of curvature. If you join C and any point on the circumference, then this angle will be 90 degree. Yes, normal. So you join this line becomes the normal. So you have this normal, you have this OA as the incident ray, then the angle between them is the angle of incidence I. The refracted ray and the normal, the angle between them is the angle of refraction R. Okay, again starting from the object, the angle in which the object is making with the principal axis in the forward direction, that is the angle alpha, image is beta, and center of curvature is gamma. Distance from the object to P, that is a distance, object distance U. From center of curvature to P, that is radius of curvature R, and from P to I, that is the image distance V. Understand? So when you write this also, you have to first describe the diagram a little bit. How will you say? You say that consider a convex refracting surface xpy having refractive index mu2 to be placed in a rarer medium having refractive index mu1. Okay. O is a point object on the principal axis. Rays of light from the object after refracting from the surface forms a real image at I. Okay, C is the center of curvature. Yeah, that much. Okay, now let us apply Snell's law. By Snell's law, this will be what? This will be mu2 sine I is equal to mu1 sine R. I think you remember why? Because mu2 and I, they are on the same side, they are on the same medium. So mu2 and I also must be in the same side of the equation. Mu1 and R, they are on the other side. Okay, please remember that. Okay, once you make a mistake here, then everything will be gone. Okay, everything will be a mistake. No point continuing once you make a mistake here. Then you remember the approximation. Instead of sine I, we write I, and instead of sine R, we write R. Call this some equation. Now let's not call it an equation. Okay, right, now if you look at this diagram once again, Look at this diagram. Let us take this diagram AOC. AOC. This one, something like this. Then you have the dotted line like this. This point is A, this point is O, this point is C. This angle here is alpha, this angle here is I, and this angle here is gamma. So from this you have gamma is equal to I plus alpha, which gives I to be gamma minus alpha. Yes or no? And similarly, let us take this triangle AIC. AIC, something like this. This is A, this is C, this is I. Then this is beta, this angle is gamma, and this is R. So from here you get R is equal to beta plus gamma. I think this is clear, no? This part. So therefore, instead of this equation, instead of I, we write this one, gamma minus alpha. And instead of R, we write beta plus gamma. Is that clear? Okay. Okay, now we take another layer, add a layer. Right, so here gamma, okay. So this implies mu2 instead of gamma I write tan gamma, instead of alpha I write tan alpha. So this will be mu2 tan gamma minus tan alpha. Mu1, this will be tan beta plus tan gamma. I think that is very clear. I don't need to explain this. Then what is tan gamma? Look at the diagram. Tan gamma. Gamma is this. Tan gamma will be AM by MC. AM by MC minus tan alpha. Tan alpha. Alpha is this, so that will be AM by OM. AM by OM. Mu1 tan beta. Tan beta is how much? Beta is this, so that will be perpendicular by base, AM by MI. AM by MI plus tan gamma. Tan gamma is this, AM by MC. Then we again cancel AM. We multiply this mu2 and this mu1 inside of the bracket. Mu2 by MC minus mu2 by OM, mu1 by MI plus mu1 by MC. Let's call this equation 2. But if you look at the diagram, what is MC? MC is nearly equal to PC, and that is equal to 1. MC is nearly equal to PC, and that is equal to minus R. Why minus? Because it is on the left side. So this will be minus R. OM, this is nearly equal to OP. And what is OP? OP is minus U. Minus U. What about MI? MI, this is nearly equal to PI. PI from here till here, that is plus V. Okay, so therefore put all these quantities in equation 2. You get mu2 by MC, that will be minus R, minus mu2 by OM that will be minus U is equal to mu1 by mi, that will be V, plus mu1 by mc, that is minus R. Okay, then what do? I take this. Okay, let me rewrite this nicely. This is mu2 by minus R plus mu2 by U is equal to mu1 by V minus mu1 by R. Okay, I take this part, this one I take it to the other side, and this I take it to the left hand side. Okay, so I will get, if I take this to the left hand side, then this will become plus, so that will be mu1 by R. This will be minus mu2 by R is equal to, this will remain here, mu1 by V, then this plus sign will become minus mu2 by U. Okay, so I will get mu1 minus mu2 by R is equal to mu1 by V minus mu2 by U. I can leave it here, or I can write this on the left side and this on the right side, just to keep the uniformity. Mu1 by V minus mu2 by U equal mu1 minus mu2 by R. This is the required expression, that one. Okay, now I want you to compare with the other derivations, that is when light is going from rarer to denser. So when it's going from rarer to denser, you will see that the expression is just the opposite of this. Okay, let me write this with orange. You will see that the expression is something like this. It is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. So this is when light is going from where? From rarer to denser. But when light is going from denser to rarer, this is the expression. So if you look at this expression and that expression, is there any difference? It looks very similar. Only difference is, instead of mu2 you have mu1, instead of mu1 you have mu2, and here you have mu1 minus mu2, here you have mu2 minus mu1. You understand? So the mu's, the refractive indices, they interchange places. Okay, so as long as the direction is the same, denser to rarer, or maybe rarer to denser, it doesn't matter whether it is concave, convex, or whether it is real or virtual. As long as light is going from R to D, you will always get this. As long as light is going from D to R, you will always get this, whether it is real, virtual, or whatever type of surface. Is it clear? So just be careful here. Okay, so this is interesting to note. All right, so why does the refractive indices interchange places? It is because now the light has reversed in its direction. Okay, and since light has reversed in its direction, what is happening? You will see here. This is where the change happened. Okay, before you had what? You had something like this. Before you had, let me hide this one. This one. Before you had this expression. No, this one. This expression, you had mu1 sine I is equal to mu2 sine R. Sine R, yes or no? So this is when light is going from rarer to denser. But if light goes from denser to rarer, you see that instead of mu1 you have mu2 now. Instead of mu2 you have mu1 here. So just be careful this part. Okay, let me undo all this part. Okay, so this is another important derivation. Study this nicely. Thank you.